Welcome back. So we are continuing our late bus problem. We've calculated for the bus being on time all 7 days a week and 6 out of the 7 days a week, but now we want to know at least 4 days. So I'm going to copy and paste the same table that we've been using. Okay, but now we don't want to just know the answer for one specific number. We want to know at least 4 days. So that means x could be 4, x could be 5, could be 6, or could be 7. So any of those satisfies the condition that the bus is late at least 4 days. So a couple ways we could go about this. The first is we could calculate x equals 4. We could add a row, calculate x equals 5, calculate x equals 6, calculate x equals 7, okay, and then add up those probabilities. Well, that takes too long. And what if we were dealing with a bigger problem? What if we wanted to look at between 4 and 30? We are not going to waste our time doing this, right? So here is a different thing we can do. It is called the cumulative probability. I probably spelled that wrong, but that's okay. Okay, so I'm going to say x equals 3, and I'll show you why. Okay, so n is 7, probability is 0.6, that hasn't changed. But now when I calculate the binomial distribution, okay, I'm going to do x, comma, n, comma, p, and then I'm going to add the word true. Okay, and what this calculated is the probability for x equals 3, and it added the probability, so plus probability that x is 2, and it added the probability that x is 1 plus the probability that x is 0. So it added up everything less than or equal to 3. Okay, and you say, why do we bother with less than or equal to 3 when we want to know greater than 4? But the total probability for this entire distribution has to equal 1. So I know looking from 0 to 1, 2, 3, all the way up to 7, see if we can stretch this out. Okay, I know that from 0, 1, 2, and 3, that probability as a total is 0.28, we'll call that 0.29, and that is for this chunk of the probability, which means for the other chunk, the chunk we care about, 4 or more, this has to be 1 minus the rest of it, because this whole thing has to add up to 1. So if I can clean this up a little bit. Okay, so the entire probability, all 7 options between 0 and 7, have to add up to 1. The calculator can calculate 3 and less, so if we figure out 3 and less, if we subtract that from 1, that gives us the total probability for 4 or more. And as you see, we did 1 minus this binomial dist. It was the same as adding up these 4 separate binomial distributions. Okay, so when we want greater than or equal to, we will do 1 minus less than or equal to 1 less than the number that we care about. And so that is how we can solve greater than or equal to or questions that say at least using Google Sheets.